Good afternoon. My name is Dale Nordenberg. How many physicians are out there? Can all the physicians come and sit in that chair there? Not even one to sit in that chair. So I'm a pediatrician. I've been doing healthcare technology for 25 plus years. I was probably the first guy that did data at the CDC's, the Center for Disease Control. Their Epidemic Intelligence Service was the first guy to go through that program that focused in on technology and data back a little while ago. So I'm a medical informaticist by certification and also a medical epidemiologist. And in 2010, I was minding my own business. Actually, I was going to start building products for population health. You probably have heard about that. When a major healthcare system approached me and said they were worried that patients were going to be harmed because of the state of cybersecurity of medical devices. And I thought, wow, did I miss that? Like, what's going on here? So how did I end up going from being weird as a technologist in medicine to being really weird doing cybersecurity in medicine? So there's three things we ask ourselves to evaluate if something's important. How many people are exposed? What happens possibly if you're exposed? And is it preventable? So as a public health guy, how many times does a patient touch a connected medical device every year? But if I ask a question, I need two answers. We don't go anywhere until I get my two answers. So who wants to take the first answer or guess or estimate? What? 75 what? Just 75. Good guess. Second guess? Oh, you guys, you're going to get a penalty. Man, you don't want to know what happens in the penalty, right? So 50 billion times. 4 billion times a month, patients that hit our healthcare system touch a medical device. We don't even know, by the way, how to count it. That's our best back of the envelope estimate. So I've worked a lot in standards, healthcare data standards and other types of standards. And it's interesting, I sit here, how many people here are engineers? Yeah. I mean, think about it. I'm sitting here on the outside. Like, let's say you went to the doctor, and the doctor talks to another doctor and says, this guy's got this goober, it's kind of funny shaped, and he's got 8 or 10 of these goobers, and they're like different sizes, and what do you think? I mean, you get a little nervous, right? So as a doctor sitting here listening to a bunch of engineers talking about things, right? People that are usually really precise, being really comfortable, talking about a bunch of things out there, trying to define what those things are. It's really interesting to kind of watch that, even after so many years in technology. So, the first thing I want to address is why is it important and why have I done it? I've already answered the question. 50 billion exposures a year. If a medical device doesn't work, a patient gets harmed. If a patient gets harmed, obviously we're not happy. Can you prevent it? We can engineer a lot of the risk out. So now we're kind of getting into the domain of standards, right? So what would it take as an applied public health guy? What does it take to do no harm? You've heard that before. What does it take to take this massive digital infrastructure that went from zero to a lot, from $30 billion investment from the US government, and make it safe? Well, does anybody know how to do it in healthcare? No one's trained to do this. None of the technologists are truly trained to do it. They're overwhelmed. So what do they want? Just tell me what to do. Give me a standard. If I had a nickel every time I heard that, it would be incredible. So then what happens with standards? And I'm sharing this with you because there is the UL stuff coming out. There's this 62443 that's been out, and our organization, the Medical Device Innovation Safety and Security Consortium, has a relationship with the 62443 group, and we've medicalized one piece of it. We have AAMI standards coming out, right? You've got all the NIST standards that are out. As everyone knows, we have a lot of standards. So what do we do about 50 billion exposures a year? Tens of millions of devices already implemented, and how do we make it safe so when a patient gets touched by one of these, we know it's going to be okay? By the way, I don't have an answer to that. I lose sleep over it, frankly. And so when I think about the UL standard or the 62443 standard or the AAMI or whatever it is, I want to get practical about it. So are these standards that will change the way we build devices into the future? Is it going to change the way we've implemented our environment today? Do we have the workforce to take that and to make a difference? Because I'll tell you, in healthcare, I don't see us changing things very soon, very fast. I don't know about what anyone else says. So I really feel like it's great to talk about the technical standards, but if we don't talk about how to change the calculus of risk and to measure that, and to measure if your standards make a difference, right? Has anybody ever seen a risk assessment that's been tested against its ability to truly predict risk, sensitivity and specificity? Does anybody see that? How many times do we redo a risk assessment, right? Every time the committee changes, we redo it. So it's like, as an epidemiologist, I'm saying, wait a second, why are we redoing something? We've not even proved this one works or it doesn't work. So question, so what do people think of that? Anyone? Yeah.
I think you're right on, but I have a solution for you. It's money, though. So
money.
Off the shelf, if you go into your hospital and you take network engineers in with doctors and nurses and blend them together for a team and subnet the heck out of the place, separate the OT from the enterprise side, whatever that is. I'm not sure what you do with patient records that need to be pulled into the operating room, but you need to make sure that's a small pipe. You can run around and put bump in the wire technology everywhere, do crypto between places, you can manage certs across the bumps, not touch any of the legacy stuff, and you're going to spend a fortune. You'll spend a ton of money, but you could orchestrate that. I think a lot of the guys in here that are security people could drive that kind of task force in your group, in the hospital, but I think you've got to bring all the people together and pay for them to stay together until that job is done. You know? So that's existing technology. Once you've done that exercise, you'll be able to write the reference guide for what the future product needs to look like.
So why doesn't that happen? I mean, we have a billion patient encounters per year in 6,000 acute care hospitals and probably 100,000 outpatient centers. Well, why are we sitting here talking about it? It's possible, but we're not doing it. Someone else?
I think about this from a personal perspective. Both my parents wear devices that are controlling my heart regularly. And my daughter is going to have a baby, and she's having ultrasounds on a regular basis. The level of risk of those devices and what happens if something goes wrong is quite different. So I'm thinking,
Why is it different? So give me an example of why it's different.
there's a human that is interpreting the results of the ultrasound, and so there is some judgment at this point in terms of how decisions are made and what sort of things happen when decisions that are made in the case of an ultrasound.
That's better, worse?
Well, I'm thinking it's safer if the device was hacked. We've got something, but with my parents, if their device was hacked,
It's a cardiac device?
it's a cardiac device. I mean, it could kill them. So I think to get our hands even around where do we start with this problem, it seems like that's an interesting challenge by itself. Is that part of the risk assessment?
So it's very interesting to hear people talk about patient-level risk, right? We were at a conference 4 or 5 years ago, and someone got up and said, hey, we found this vulnerability. This is a big patient safety problem. I said, well, why? Well, there's a big vulnerability. I said, well, so why is that a patient safety problem? And it's not trivial. Even if you can sort of go through the threat scenarios and vulnerabilities and do that whole thing, you know, people say, oh, an infusion pump in the ICU is a bigger risk to the patient than an infusion pump on the floor. I say, why? Because at least in the ICU, it's part of a human physical cyber network, right? If the patient actually starts crashing, the alarms go off, so you can actually probably save the patient. So it's a very complicated calculus. You know, you do an ultrasound, you get a report, and then the records get mixed up, and the next thing you know, you're doing fetal surgery on a baby that doesn't need it because the ultrasounds got mixed up. So as an epidemiologist, I look at this all in terms of analogs. I see a universe of risk that we've created. It's an enormous universe of risk. I think we're not imagining how it's going to go wrong. I mean, I think it's interesting to do that, right? We could look at the infectious disease world to understand what might go wrong in the silicone-based populations of devices and malware and worms and all the other kinds of things that are infectious and moving around. So I think that the issue of analogs, once you move towards recognizing the scope of this problem, and in my business, not to say in anyone else's business, it's not important. In my business, it's acutely important. And the doctors don't care yet. Just starting this past 6 months, they're waking up. WannaCry, shutting down hospitals woke them up. So I think we talked about this a little bit before. If the network is very complicated and there's almost infinite number of devices and the standards are very difficult to apply, what do we do? Right? I mean, we have to be engineers about it, ironically, right? Doctor talking to engineers. And we have to be very, very realistic about it. And I think this is the challenge. We can't just think we're doing a great job. We have to force ourselves to define the problem and to measure our progress on the problem. Is anyone aware of us doing that in any way? In healthcare, we haven't done it. Anyone see that in any other industry?
If you go back and look at the beginning of this presentation, what did they say about what an IoT device is? They said it's any device that's connected to the network. So if you look at the problem that we just stated we're trying to solve, it's let's come up with a framework and try to figure out how we're going to manage every device that's connected to the network. And we're not the first people who've tried to do that, but the people who've tried to do it in the past have not been successful because it's a very difficult problem to solve. I don't want to say it's impossible, but it's like trying to contain the ocean. So it's been 10,000 years and we still don't know how the ocean works. So if we're going to solve this problem, I think the most reasonable thing to do is to scope it down. Because under the current definition of we're going to figure out a framework to manage every device that's on the network, it's not realistic.
And yet we're dependent, people and populations are dependent on our ability to figure out that problem, the answer to that problem. That's the question. So we know that when you look at what we're challenged with, our ability to build a smarter, bigger workforce for this infrastructure is moving at some fraction of the rate we can build and deploy devices. So we're just losing ground every single year. So you're right, something has to change. So I guess, I'll wrap up in a minute or two. So when I think of standards, I think, man, they're just too slow, right? And so where do standards and best practices interface or interact, right? So I think we need to get much better about best practices that we're pushing out, iterating in a really agile way, and how those relate to the standards so that we've got a way to actually get better in a quasi-standardized way and in an agile way, but then that learning gets pushed into the standards. So I think it's really worth it for us to think about that in a lot more detail. So one of the projects we're working on is we're calling it the National Cyber Safety Network. It's a 100% analog of the National Health Safety Network that tracks infections in patients. We're starting to track infections in computers. We're applying public health best practices to understand what's going on, to collect the data to understand, because no one has any data. So I just want to wrap it up by saying standards are great. I've been working in the standards domain for a very long time. We all know any given standard can be applied in infinite number of ways. That doesn't mean we're going to be doing it the same way. And we have a problem that's expanding at a much faster rate than our ability to understand it and to actually build the capability to respond to it. So I think we have to change the paradigm, and I guess that would be the call to action to this group of engineers, is how do we change the paradigm and how do we put that into the standards? Question?
Yeah, do you see a difference between, I've got three questions. You see the difference between IoT and IIoT? I heard that maybe there is no difference coming from over here. I think there's a big difference. And what is that definition of IoT versus IIoT?
So I'll just tell you the way I look at this. So if I look at a hospital, people say Internet of Things or IIoT.
No, they're different, I think. But
No, it's okay. So I look at it, I say, okay, well, I have medical devices, and I have medical devices that are implanted in someone's chest or in someone's brain, and then I have medical devices that are bolted down and shooting proton beams into people's head, right? Then I have things that are mobile or not, wireless or not, and the diversity is enormous. It's the animal kingdom. And then you've got industrial control systems. Now, there's some industrial control systems that will be, from a genealogy, if you did a gene tree, it would be closer to some medical devices. Then some medical devices are closer to other medical devices. And yet we make this distinction. And then we've got the IoT, which is everything else. And you want to know something? If a threat is going to be looking for a vulnerability to exploit, if that makes any sense in English, and if at the other end of it, it's a bad event, they don't care what you call the device. So one of the reasons we're interested in something like 62443, and seeing the UL standard, I think it's there as well. You have to have some paradigm that cuts across everything. It's just devices. They're not things. They're just computing devices that they're out there. We have to get rid of this whole notion of that they stratify and they segment and stuff like that. So
No,
sorry, I can't answer your question.
I think there should be a clear line between IoT, for example, if it's a pacemaker, and you know you have to run it through a web service where it touches the internet, you better make sure you've locked that down and understand it well, right? But in general, I would say don't run any IoT devices across the internet. That doesn't mean don't use internet protocols. That means you've got a control system. You do air gap it as best you can. You know where the points are that it's not air gapped. For example, customer records. Maybe you want your customers to be able to access their own records. Well, it's got to be put out there somewhere so they can have access through the internet. But once you get it, well, that's a tough one. I want to build some crypto into it. I'm going to encrypt. Here.
I think the argument is less around it being this is our problem. There's a due care process problem that we have to address, and that we
what?
need to go at a due care
Like DO?
process problem.
Like I do care about.
No, like D-U-E, care.
Got it.
I developed something, deployed something, it caused mass disruption, potentially killed people. Who's responsible? The person who bought the devices, the company who bought them in bulk and deployed them, or the person who sold those devices, did no analysis on the code and distributed it? I mean, you put stuff out there, right? So I mean, they did their best by deploying airbags, but those airbags were faulty. Did we go after the car driver who smashed into something to find out that those airbags were bad? You know what I mean? So the point kind of iterates over and over again, right?
Yeah, so over time, I think once you see something is bad, like an airbag, then you fix it, ultimately, in the next design. I'm not sure we're fixing things. So back to your comment about standards, which from my view are a collection of requirements. And I've seen tons of them all over the place. And people think about it, but I see no best practices based on best practice. Our understanding of what we believe best practice security should be. I see a lot of bump in the wire stuff. I don't see anything built into the devices themselves, really. Inside of healthcare, in DCS, inside of the grid, whatever. So that's just a comment. And what do you think we can do to move that forward? Because it costs a lot of money, and vendors need to know what to do, what steps to take.
Yeah.
Right?
It's not the money's fault. I don't want. We're already like in the Q&A.
Yeah, I was just.
I'm taking Sid's job here.
Yeah, I'm just wondering. I mean, it's fine if we want to pursue that. I mean, I don't know if you have questions for any of the other panelists, or if any of the other panelists have a chance to comment on the questions. I mean, I was going to make a comment before when I think Dale's the one that said it, but that there's this enormous number of different problems. I'm not so sure they're different problems as much as they are different devices being used different ways. I mean, that's how I frame it. Maybe it's not right, but I use the frame of use cases. I mean, somebody takes something that's perfectly well-defined, perfectly understood within a power plant, and then they go and they put it out on the street and they use it a different way, and all of a sudden it's insecure. Well, it's because you used it a different way. And I think the same is true with medical devices. I mean, if you constrain the problem and you say, here's a device that sits inside a certain environment, which could be an operating room, but it could be a hospital environment. It has to share certain things, and you well define that. Personally, I think one could secure that. The problem is there's an infinite number of use cases, which is my issue too, but I don't know what will happen, but I don't know how you do that. But.
So when you say we could do that, and we could do that, I agree 100%. We could do that, hypothetically. But, the leading cause, here we go, leading cause of infectious disease death today is due to what bug? Flu. No? What else? What? Staph?
Opioids.
Okay. Tuberculosis. Yeah. We could treat and get rid of tuberculosis. We could get rid of malaria. How many diseases have we ever eradicated? One. So the real world is a lot hairier than the ability to actually constrain the real world. And that's where I think our challenge is, because we can see it, right? The speed that this is changing, it's like there was a big bang, and man, this thing is just expanding exponentially. If we keep trying to catch up to it, we'll never do it. So the question is how do we get out in front of it? How do we change the paradigm entirely? And from a patient care perspective, 10, 12, 15 years ago, there's no digital health infrastructure. Now it's only digital health infrastructure.
So thank you for the moment. A very interesting topic, and this is not a topic that's just specific to healthcare. It goes across the industrial marketplace as well with our automation systems. And some of the people in here have commented on, we get down to rudimentary control languages and processes and methodologies, and that's an issue. We're not going to change that. We can go back 30 years. We still have to deal with it. The fact is, how do we go forward and prevent it, and how do we mitigate that risk looking back? And the way to do that is to look at the data collection and analytics of that data and putting modeling in place, just like you do with software when you develop to create traps for bugs so that you inhibit those traps from mitigating your control or limiting your functionality. And when you identify functionality issues or operability issues, that's whenever you call to task an alarm or something that makes everyone aware of it so we can work on the problem. So you have to use mathematical models, and you have to start looking at putting traps in place that stop these things from allowing themselves to manifest themselves, and stop looking at how do we deal with trillions of data bits, because that's what you're talking about with 50 billion devices. And it moves us off the paradigm shift. You asked for the call to task, it's about data analytics.
So I've got a comment on this. So one of the things that tends to be the focus of the standards and how we're responding to these various fears is prevention. And so a lot of energy's spent on that. One of the things that my colleague Marty Edwards emphasizes is that we should look at consequence reduction and consequence mitigation. So it's not a if something is going to happen, it's a when. And the easy analog to that is you're driving cars and you know the car is going to get in a wreck sooner or later, or you're going to get in a wreck. And so there are some technologies to prevent that. Automatic braking systems, lane change gizmos to let you know that somebody's there. But if you actually get in a wreck, there's consequence mitigation, airbags, seat belts, things of that nature. So in an industrial environment, the safety world looks at this too. But I just don't see a whole lot of work that's been done on the consequence mitigation side. I think that's something that could stand a little more study.
So that's one of the things that we're building as a consortium, the National Cyber Safety Network. So the consequence, we need case definitions. You can't count something until you can define it, right? And no one's started to count, at least in healthcare, what's going on. So if, or it's not if, it's when, but what about the past tense? What did we miss? So the notion that if and when, I think it doesn't address the fact that in 50 billion exposures, has a patient been adversely impacted by a cyber event on a medical device? Who thinks a patient's been impacted in the last 12 months? One out of those 50 billion times the patient was harmed due to cyber. Who thinks that happened? Who thinks it didn't happen? Okay. I think that's the point. Thank you very much.
I didn't want to make you moderator. I just swapped because I didn't want everything to be forced around medical devices because he was moderating. So, but that was fine. But that was fine with me if that's what the questions are. Are there other questions? I really enjoyed the discussion here. And yes.
One last comment I want to make is that you brought a very good point up. This is not an individual.
This problem is not an individual segment or industry problem. It is a human nature problem. This is something we've got to work on together and collectively address. And I don't think that there's one person in this room that can solve the problem. It's models that come out of medicine. It's models that come out of engineering. We know these things. We study them in school. They've been studied for hundreds of years, actually. We need to apply the greater sciences to help solve these problems of fundamental value. And they will correct the issues, because as soon as the people, as this gentleman pointed out back here, that as soon as the people become the point for analytics, there's an opportunity for us to miss something. So we have to build it into our data sets and create the analytics at the edge device so that we can stop these problems from occurring and we can mitigate the risk. And standards obviously will help do that across the board going forward, but it's the post-mortem problem that we got to deal with. It's what's happened in the past that wasn't corrected, and that's the bigger risk. So that's all I have. Thank you.
I have some questions if others don't, but please, you know, the point is to give you a chance to ask questions. Go ahead, Mark.
I have an opinion question.
Opinion or a question?
Well, an opinion question. We're dealing with a problem of almost infinite technical complexity. So where did that almost infinite technical complexity come from?
I don't understand the question. You asking me? Well,
Yeah.
Who wants to answer? Because I don't understand the question. I honestly don't. What? Let me, with regard to answering your comment question, let me just ask a question here, which I was going to ask, which it doesn't answer it, and we'll get back. I mean, it addresses it. But my question was, Eric mentioned, because Eric's on a committee which is part of ISA 99, and the task force, the working group 9, task force, whatever, I'm sorry, I don't remember those numbers, but the task was to look at IoT, and I'm assuming, let's say it's the same as IIoT, so we don't get into that discussion, but it really was devices, IoT devices for industrial things. But to look, and I understood from what your slide showed, or it was more on your slide, that you were looking there to say, what is there that's different that we don't have covered right now? What are those differences? So with respect to your question, I'm saying, what are the differences? I mean, because my own opinion, just to be frank, you know, I think it's a generally accepted kind of a standard. I mean, it's good logical standard, the IEC 62443 standard for protecting. I always see it as facilities in particular, and I guess also maybe SCADA systems, but very much focused on the traditional kind of plant to me. So in a way, I know that doesn't solve all problems because people can get by anything, but it's at least got a constrained that problem. So now what difference is there in the IoT thing that you have found in your committee?
Yeah, I think there's a lot of differences that we're looking at. I mean,
Is this getting to your question in a way, I'm hoping?
Don't know yet.
Okay.
we'll see. Yeah, so I think you know, there's differences that we're thinking about. You know, when you think about the industrial Internet of Things, and I think about how our customers are using our devices, they're deploying things out in the field, and they expect them to be work and be supported for 10, 20 or more years. You know, when I think of just general IoT, you know, my webcam at home is only going to be supported, you know, for maybe a year or maybe not that long. So, you know, that's one of the big differences that we're looking at. And yeah, I don't know. Other differences that are popping into my head.
I mean, that would seem to me that the IoT is an easier problem than the plant. I'm saying one of the big issues that people talk about with plants is the legacy equipment and managing that. I mean, there was just recent events where, you know, I don't want to mention any companies, but, you know, there was a major problem found, an attack, and the equipment was, I think, from 2004 or something like that. And so if it wasn't secure, it's not a surprise. So, but I'm saying, and where usually people say, well, the newer things I can't imagine anybody now a responsible automation company today would be building products that without using a secure development lifecycle, doing everything they could to make it secure. I'm not saying it's perfect. I think we'd all say it probably isn't, but it's doing the best you can. Where you can't necessarily say that for everybody that's making a camera for your house or something like that.
I think there's a bigger expectation on security too with the industrial Internet of Things than with just your standard commercial grade devices. You know, we're developing products, and I see firsthand how difficult it is to make a product secure. And when I think of, you know, time to market and some of these commercial companies trying to get out, it's not surprising to me that you don't see a lot of security in these devices. It's very difficult to build a device right and make it secure and, essentially provide the end users with the locks to lock the door, essentially. So, yeah, a couple of big differences that I see with industrial's Internet of Things.
Ken, did you want to make a comment?
Yeah, when I look at it, and if you compare last century to this century, and Eric hit the nail on the head, I think, for me, when you consider IIoT and IoT, it's really simple. It's like the longevity, how long that component or device is going to be deployed. But who cares if you call it IoT or IIoT? Let's not, we're security professionals here. We can get caught up for years and years and years in the debate of what to call something. Why does it matter? The end
Just
of the day.
don't call me late for dinner.
Exactly. At the end of the day, you look at last century. In the last century, people were building products. And then in the 1950s, 1960s, they introduced GFCI. Anyone here familiar with what a GFCI is? Right. So before that, things used to catch on fire. It used to shock you. It cost those manufacturers money to invest in developing and designing GFCI technology and building it into their products, right? The new challenge for this century is security. Last century was safety. So I think what we need to consider is security is not this magnanimous, and I think the question from the person who presented was it's an all-encompassing, problem. It's not, nothing is infinitesimal unless you start looking at chaos in the universe. It's associated with the length of code that's written. It's associated with the amount of technology that's in it. And so solving the problem is just putting your minds together and putting an input into it. I look at an example that happened Christmas of last year where there was a particular phone manufacturer and their phone caught on fire. And then all of a sudden you'd get onto a plane and they would announce, if you have this particular model, you're going to get kicked off. And they put scanners onto the plane to detect if you had this particular model, and it was turned on. That was an immediate response within 30 days of this happening. This should happen also with security. It just needs to have that, it just needs to be bubbled up to that importance, just like safety for this century.
Question.
Okay, there's a question from the
Not
floor.
just
Okay,
a
good.
question, but I think it's a good analogy, yeah? So how to get focus on something which is really important. So you explained manufacturing and safety and how consumers kind of rally and say, hey, we don't accept this. Well, think about what happened last year with Equifax. Half of the US population lost their data. And Congress sleeps on. And for me, so it's not important. So if it's not visible,
Yeah.
if it's not exploding, if it's not on fire, everybody says, hey, it's okay for us.
I'll respond two ways with that. First off, I don't think anybody here could explain Congress. But
That wasn't a question, it was a comment.
It was a comment.
Comment question.
I think it really starts with us. What I like to believe is we all have purchasing power, whether we have it in our individual lives or whether we have it in the organizations that we represent and support and participate in. And so we use that purchasing power to slowly start to reward companies that are investing in security. So would you today buy something that fell off a truck, or would you today buy something that was in a nice retail store and probably has a UL logo or some other, you would go after somebody who invested into it, right? So what it means right now is, like you said, we don't care if it catches on fire. Well, it's up to all of us. We have the purchasing power to start caring. Now, you may not be able to convince your congressman, but it's time for us to start doing the research and doing the due diligence. And like Eric said, Emerson's spending a lot of money in this. Look at Emerson and say, okay, if they're spending a lot of money, I'm going to focus my spend on Emerson. And I'm not going to focus my spend on companies that aren't. But we all have to take that investment. It's just like buying food too. So if we can all individually start to do this, and that's that paradigm shift that Andre was talking about, we'll get the ball rolling. And that's how it happened with safety.
And the same thing, Andre, I was going to give you a chance because I think it's relevant.
Informed consent. How do you know? And so that's why I still stick by the fact that the standards are important and conformity assessment to them. Like Ken was mentioning, you have a UL logo on there, and so you have confidence. The issue with cybersecurity, it's so complex. The average guy on the street, the average manager in a company doesn't know how to evaluate products or evaluate their operations, people, process, technology. So, the standards come into play here, and they're helpful.
Are the companies, one thing about ISA, I know with ISA Secure, I think the same is true with UL 2900 these days too, is the interest by suppliers to get their products certified. It seems to me that that's growing. I mean, I talked to suppliers a few years ago, and they assured me, they go through good practices, and I believe them, but they just said, but this final step of getting a certified, and all, he said it isn't important to our customers, was kind of the attitude. And they just didn't think it added anything. They said, it's very expensive, it's time consuming and all that kind of stuff, and we're really doing everything, so they felt comfortable. But now I get the feeling from talking to you guys, but that it is picking up a lot more now where companies are demanding, they're saying we're only going to buy products from suppliers who have certain certifications. Now that may vary by country. I understand that's a big challenge.
Yeah, it's taking the same trajectory as safety, the 61508. That's been around for 30 years, but the same issue existed there. The number of safety experts that were on staff at companies was small. There just aren't enough, and so all the expertise and the knowledge is codified into the standards from this 500-person committee that put this together, and that's what standards are there for, to be able to efficiently move best practices and knowledge around and have them applied. And so I think that it's just recent that the standards were completed, and so, like you said, the suppliers are looking at these conformity assessment schemes bubbling up, and they're waiting for their big customers to say, look, we really need you to do this because we've run out of capacity to do the evaluations ourselves.
Luckily, that's a smaller group in the industrial space than it is in public, where we'd all have to do it. Dale, yes?
So first caveat is everything we talked about with medical applies to non-medical, right?
Right.
And I like the discussion about, this notion that I think defining IoT or IIoT. In fact, I think ultimately, one of the definitions that was shown was any device, right? I think it said any device. So I think it's really important to get rid of those borders because the types of devices that are coming out just gets more and more diverse, right? So the comment was made a little bit ago about consequence. We should think from the perspective of consequence. So, one of the questions I ask, and I think this is true, there's a maturity process, and we have to accept that. It's like living on the technology adoption curve, right? Everything we're doing is a technology adoption curve. Standards are critical. That's why we all spend time on them. So what I do is I ask people how long should it take, for example, for a hospital to know all the cyber attributes of the medical devices in the hospital. Let's just say all devices in the hospital, cyber attributes. Because right now, what percentage of the medical devices in a hospital have known cyber attributes? It approaches zero, right? So they're black box networks. So we say, okay, it should be 3 years. So I go 3 years. It's like saying here it's going to take 20 years or 15 years. But if you attach that to a consequence, it gets interesting. So then you say, well, 3 years, that's 150 billion exposure time frame. Well, that's pretty interesting. It gets more interesting when you say we don't even know the consequence of those exposures. So I agree 100%, standards are critical. I agree 100%, there's a maturation process. And then the question then is, how do we map that back to understanding consequence? And how do we understand what it means to do that weighting? And how do we use that to maybe accelerate our commitment, either financial, right, because people would be motivated by the money in the business, or by the outcome. So I think that's one of the interesting linkages that's still missing.
Isn't that, to me, as you were talking, I agree with everything you just said, but the one thing I would think is that, impact, I agree with that whole point, by the way. I mean, I'm a big proponent of that too, reduce the impact. That's very dependent upon, my term for it is use case. I mean, the impact for a power plant, if something goes down, is quite different than the impact in a hospital, and everybody's got to evaluate themselves on those issues using the kind of numbers you just did. I mean, I think it's a shame that if with those kind of potential risks, and I don't know what those exposures mean, as you just said, but, but hospitals certainly should feel obligated to address that, or the government or someone like that, to say we have to do it. It's like, we have standards in other industries. I don't know if, it's amazing to me, I mean, I go to the doctors and I spend all my time, I've gone to the emergency room, and instead of taking care of me, I had to sit there and answer all these questions, and 5 times as I went through the system.
So-
So they're very good with information, but not with, with doing anything with it, is my frustration.
You could do the same thing in an industrial control plant. You could figure out exposures in a meaningful way, exposures to, critical systems or something like that.
We already do that. That's my question. This is Adam Friedstrom with Dow Chemical. I was going to ask the question, how really is this different from process safety? In process safety, we worry about layers of protection, we worry about exposure limits, we spend time analyzing, the risks, and this concept of do no harm is very real, especially in a chemical plant.
Responsible care, do you still use that term?
Yes, responsible care. How do we prevent injuries to our people? How do we prevent exposure and injuries to the general public? And so there's a lot of thoughtful design, a lot of thoughtful analysis that goes into how we control and how we protect. And so how is that different from the medical industry in terms of the approach and how you solve those problems?
I would say it's no different at the end of the day. I think that's the answer. That's my answer to that question. I think this distinction that was made between safety and what we did with safety before, and now cyber. Well, cyber is also about safety, right? Mm-hmm. It's one of the root causes of safety. So
I'm sorry.
I think it's so. I guess the question I would have is cyber different? So if you're driving a car and you hit a wall and your head hits the wheel or the windshield, it's pretty clear what's happening, right? Headrests, seat belts, airbags, right? Anti-lock brakes. But when you're doing, is cyber more complex and is cyber more challenging today than those other problems were?
Well, I think one big difference between safety and security is, with safety, you're trying to prevent against, some inadvertent problem. With security, you've got someone that's actively trying to subvert these controls that you put in place. And I think that's a pretty big difference.
I think that's one of the evidence when you use hazard-based safety engineering and try to apply it to security. But one of the things that's really easy to look at is that safety has a 100+ year history behind it, with a lot of training, a lot of education. Today, anyone here who's a manufacturer, if you hire someone coming straight out of college, that they would most likely have the principles on safety embedded in them and drilled into them. Security doesn't have that. Well, you can hope. You can hope, right? But security doesn't have that. So Eric mentions a good point. You actually have an active person trying to circumvent what you've put in there. But the truth of the matter is, security is like the baby, while safety is like the adult. And we just have to nurture that baby.
Isn't it also, because I teach statistics, so one of my things is when you look at that, and one thing I've seen in safety is there's a lot of reliability data all over the place. And so, I can calculate to you and tell you the potential failures or mean time between failures, and that tells me I need to go to a certain SIL rating or I have to put in backups. That's, and the problem with the cyber is there is no data. And most people will say it's never going to happen, and we worry about black swans and not really the recurring kind of incidents. And I think that, I personally see that as one of the big challenges.
Yeah, so I'm agreeing with what everybody's saying here.
That's a first.
The safety world, it's called functional safety, and you have mathematical equations for computing it. And based on those equations, there's a lot of history that's been fed into it that tell you outcomes, that sort of thing. For cybersecurity, we're just getting there. We don't have a formula yet. But if you were going to do security level function formula, it would include security capabilities of your technology, process and procedure maturity at the operating plant, and the personnel training and knowledge. So you'd have this function, and you have each one of those, and you look at how good the goodness level of each one of them, and have with a coefficient, and come out with some measure. So you got a formula. Now we need 20 years of stuff going bad to feed into that to see what it's telling us about different things. Is it more of a training that's broken? Can we get more bang for the buck on that? Do we get more bang for the buck on adding new technology? Is it your policies and procedures? And so to the extent that the standards get to the point of defining some kind of objective function, and we can then start feeding that monster, I think we'll start progressing.
Oh, you got one more question. So last question, because it's 3:30, so. we should
This is
stop.
Dion Ray from Chevron, and just want to thank the panel. Really good discussion, and this is what we need to mature these technologies. But I just want to share, we've deployed our first IoT project at a manufacturing facility where we right up to neighborhoods where we've been watched like hawks every day, and it will not impact safe operations. But what it will do is help us with predictive diagnostic on major pieces of equipment that will help the facility to be more reliable. And the reference architecture we follow is very similar to the NAMUA 8.2, for those that's familiar with it. So I think there's definitely space where we can move ahead, and we should push ahead with this IoT usage in the non-critical applications. So when people talk about IoT sensors, medical or industry, don't confuse it with your normal automation systems that's used for critical control and safety systems. It's not the same. It's complementary. It doesn't touch it. It's air-gapped at the sensor level. We've got a data diode or firewall protecting it. It's in this outside layer. And I think there's a lot of work we can do in that space, and the more we work in that space, the more mature and rugged it will become.
Okay, well, let me, hope you join me in thanking the panel. I enjoyed this discussion very much. Thank you very much.